Just a second. Yeah, it is great, folks. I hope everything is good, everything is fine, everyone is fine. All right. So let's get started with the data science interview questions day 3. All right, everything is able to hear. We'll just check it. Everything is working fine or not. Okay. Let me check the YouTube channel. Am I getting it or not? I will just check it. Everything is fine. Everything is fine, folks. Am I audible? Everything is fine. Everything is fine, folks. Am I audible? Yeah, everything is pretend fine now. Okay, so let's get started with the interview questions, with the data science interview questions, day 2. So ping me, folks, if you have a doubt with regards to that. Okay. Okay, so what I do is I will just separate it out with this one. So I will get this particularly. Okay, so let's get started with the interview questions, folks. So we'll get back to day 3. So we'll just try to understand the day 3 questions. Okay, all right. So what we'll do is now we'll try to understand how do you treat hetero heteroscedasticity in regression. All right. So what we'll do is we'll take a two questions right now. Okay. So we will try to understand that part in depth. We'll step by step and understanding in very slow manner so that you will understand what we are trying to achieve actually, right? So day 3, I will be just trying to divide the questions basically, folks. Why? Because it's like huge 18 questions, right? So let's get started with it and try to understand with regards to that. How do you treat the heteroscedasticity in regression? Okay, so heteroscedasticity means unequal scatter distribution. Okay, so let's get started. We'll just take the obsidian part and we'll just try to understand what this is all about. Okay, so let's get started with that. Canvas. Okay, so let's get started. So we'll just take the big thing and here, how do you treat heteroscedasticity in regression? Okay, so heteroscedasticity means unequal scatter distribution. Okay, so heteroscedasticity means unequal scatter distribution And in regression analysis, we generally what we generally talk about the heteroscedasticity in the context of error term. Okay, are you understanding? So heteroscedasticity will be means unequal scatter distribution. So what we understood from this, heteroscedasticity is nothing but unequal distribution. So what you can do is you can write it like uh, take a roadmap of like this. Okay, take a unequal distribution here basically. So heteroscedasticity is an equal distribution. Then another part is like in regression analysis, we generally talk about the heteroscedasticity in the context of error term. Okay, so in terms of a error term, we'll be talking about it. So you can just expand this. Okay, in regression analysis, heteroscedasticity is talked about in the context of error term. Okay, so heteroscedasticity is a systematic spread of residuals on the errors over the range of measured values. Heteroscedasticity is a heteroscedasticity is the what? Is the problem. It's a problem because ordinary least squares OLS Lagrange assumes that all residuals are drawn from a random population and that has a constant variance. Okay, so understand like this basically. So ordinary least squares assumes that all residuals are drawn from the random population and that has a constant variance. Okay, so what you will understand heteroscedasticity is a spread of residuals over the errors over the range of measured values. Okay, understand like this. It is regression is generally talks about heteroscedasticity in the context of error terms. Okay, so third thing what you can map it is heteroscedasticity is a systematic change in the spread of residuals or errors over the range of measured values. Heteroscedasticity is an unequal distribution. In regression analysis, we talk about it in the context of error. Heteroscedasticity is the problem because OLS. Just a second, folks. Hello, hello. Yeah, yeah. They will get back to me like that. They do. Yeah. Okay. Okay. Okay, folks. So this is a particular thing like regression assumes that all residuals are drawn from a random population that has a constant variance. So what causes heteroscedasticity? Okay. So you understood like over uh, is a systematic change in the spread of errors you can talk about or change in the spread of residuals over the range of measured values. Okay, it is a systematic change in the spread of errors over the range of measured values. Simple. You have to understand like this heteroscedasticity means unequal scattered distribution. Second, in regression analysis, we generally talk about the heteroscedasticity in terms of the error term. Heteroscedasticity is a systematic change in the spread of residuals. Okay, change in the spread of errors over the range of measured values. Heteroscedasticity is the problem. Okay, because OLS, like ordinary least squares, assumes that all residues are drawn at the random population from the random population, which has a constant variance. Okay, so now the question is what causes the heteroscedasticity? Why the error will cause? So heteroscedasticity occurs more often in a data set where we have a large range between the large and smallest observed values. Okay, why the heteroscedasticity is causes? Why? Because it is a ranges between largest and the smallest observed values. Okay, so now the question is, you can make a notes like this, folks, so that it will helpful you whenever you are having an interview, right? So in the heteroscedasticity, we have a what causes the heteroscedasticity. So heteroscedasticity occurs for this particular reason. It occurs more often in a data set when we have a large range between the largest and the smallest observed values. Okay, so occurs, you can write it like this and you can put it in the document. Okay, like this. You can put it in Obsidian, folks. Okay, so that it will helpful for you. Okay, so they have also um free tool as well. Okay, so you will get Excalibur as well, you can do for that purpose as well. So what causes heteroscedasticity? Heteroscedasticity occurs when we have large range between the largest and smallest observed values. Okay, there are many reasons for heteroscedasticity can exist, and generally explanation is that error variance changes periodically with the factor. We can categorize so heteroscedasticity into the two general types. One is a pure heteroscedasticity and another one is impure heteroscedasticity. So pure heteroscedasticity, it refers to the cause cases where we specify the correct model and let us observe the non-custom variance in the residual plots. Impure heteroscedasticity, it refers to the cases when you incorrectly specify the model and that causes a non-constant variance. Pure in the pure, what happens? It refers to cases where specify the correct model. Okay, so how you fix this? Okay, when you have a leave an important variable out of the model, the omitted the effect in the observed in the error term. So how do you fix this? You will redefine the variables. If your model is cross-sectional model that includes large differences between the size of the observation, you can find a different ways to specify the model that reduces the impact of the size of the differential. Okay, so I know that this is the thing will be the thing. Okay, so another question that can be asked is, what is a multicollinearity? How do you treat it? Multicollinearity is what? First, you explain them. What is a multicollinearity? Multicollinearity means independent variables which are highly correlated to each other. Okay, so multicollinearity is what? Means independent variable highly correlated to each other. Okay, so you can just highlight this. Means independent variables which are highly correlated to each other. Okay, so you can just highlight like this. Okay, so in regression analysis, it's an assumption that regression model should not face with the problem of multicollinearity. In the sense, it should not correlated with each other. If two exploratory and variables are highly correlated, it's hard to tell that which affects the dependent variable. Let's say y is a regressed against x1 and x2 and x1 and x2 is highly correlated, then effect of x1 on y is hard to distinguish from the effect of x2 on y because any increase in x1 tends to be associated with the increase in x2. Another way look at the multicollinearity problem is individual t-test p-values can be individual t-test p-values can be misleading. Okay, so it means a p-value can be high, which means the variable is not important even when though the variable is important. Okay, so how do you correct this multicollinearity? Remove one of the highly correlated independent variables from the model. If you have two or more with a high VIF, remove one from the model using the VIF. High VIF, remove one from the model. Second is PCA. Cut the number of interdependent features to the smaller set and uncorrelated components. Instead of using highly correlated variables, use the components of the model that have the eigenvectors which is greater than 1. Run the proc var class. Choose the variable that has 1 minus 2 ratio with the cluster. Ridge regression, it is a technique for analyzing the multiple regression data that suffers from the multicollinearity. If you include the interaction term, the product of two independent variables, you can also reduce the multicollinearity by centering the variables. By centering, it means subtracting the mean from the values of independent variables before creating the products. Okay, so when is the multicollinearity is not a problem? If your goal is to predict y, from the set of x variables, then the multicollinearity is not a problem. Okay, the prediction will still accurate, and overall R2 or adjusted R2 qualifies how well the model predicts the y values. Multiple dummy variables that represents the categorical variable with two or more categories. So then they may ask like what is a market basket analysis? How would you do in Python? Market basket analysis is a study of items that are purchased, grouped up in a single transaction or multiple sequential transaction. Understanding the relationship and the strength of those relationship is valuable. Information that can be used to make the recommendation, cross-sell, upsell, and offer the coupons, etc. Market basket analysis is one of the key techniques using the large retailers to uncover the associations between items. It works looking for the combination of items that occurs together frequently in transaction. To put it another way, it allows retailers to identify the relationship between the items that people buy. What is association analysis? Association analysis, where it is used. Association analysis it uses a set of transaction, discovers the rules that indicates likely the occurrence of an item based on occurrence of other items in the transaction. The technique of association rule is widely used for retail basket analysis. It can be used for classification using rules with class labels on our right hand side. It is even used for outlier detection, which rules indicating infrequent or abnormal association. Okay, so these are the thing, folks. For this A to B support or confidence, you will be going to find it out. Like part before, as if the antecedent, and a part after is referred to as then consequent. So antivirus software, like how it is, how much support and how much confidence. That above rule says, okay, so like 60% of customer who purchase antivirus is bought with the purchase of computer. An example of association rules, assume there are 100 customers. Okay, 10 of them bought milk, 8 of bought butter, and 6 of bought both of them, and 2 bought milk and bought butter. Okay, support is P of milk and butter. What is the probability of that? Confidence is support divided by probability of butter, getting the taking the butter basically. Lift, which is confidence by probability of milk. So they can ask about the KNN classifier, folks. Okay, this is a general questions they may ask. Okay, KNN means K nearest neighbor algorithm. It can use for both classification and regression. Okay, so folks, in the next video we'll be going to talk about it because I am running out of the time and there is an electricity issue here. So in the next video, next live session, we'll be going to continuing this. What is KNN classifier? All right, that's it about this video, folks. I am ending this particular video right now. So I we will be wrap up this now. In the next live session, we'll be going to discuss about